So we have a bearing for an axial flow compressor. So need to carry a radial load of 2500 Newton and thrust force of 1500 Newton. So thrust force and axial force are both the same thing. So axial force or thrust force is 1500. We have the service imposes light shock and the bearing will be used in for 40 hours per week for 5 years. That's the time period for the usage of the bearing. Shaft speed is also given as 1000 rpm. Then we have to select the suitable ball bearing for the purpose. Okay. So first I have written all the given condition. You can see the radial load. It's you see the radial load 2500 Newton. Thrust is also given as 1500 Newton. Speed of the shaft is also given. Diameter is also given. So first thing we have to calculate in the case of this ball bearing problem, we have need to calculate the average life. Okay, that's the first thing we need to find the life of the bearing revolution as ultimate aim and the only factor we need to solve this problem. So how to find life of bearing in revolution? Before that, we need to find average life of bearing for the given time period. In this question, the given time period is 40 hours per week for a time of 5 years. So how much hours? We need to convert that whole thing into hours, simply hours. So let's this crack it down. So they're saying 40 hours per week. 1 week, 7 days, but all 7 days, just assume that 2 days are not working. I mean, Saturday and Sunday you have to neglect. That's a general assumption. Uh, when we solve this type of problem, we won't be considering generally all the days working day. So assuming 5 days to be working, so 40 hour per week, that means 40 hours for span of 5 days. Okay, so assuming 5 working days in a week. So 1 day that will be around 8 hours. Okay, 5 days and 1 day that will be around 8 hours working. So we know one the time can for a single day, that's 8 hours. So in a year we know there are 365 days. There also we assuming there are only 300 working days. Okay, in a year there are 366 or 365. From that we are just assuming 300 working days. So assuming a 300 working day, each day take 8 hours of the working time is 8 hours. So for 300 days working day, that will be around 2500 hours per year. Okay, 1 year assuming a 300 working day, that will be around 2500 hours. So they are asked about 5 years. This whole thing is saying about 5 years. So this 2500 into, sorry, 400 into 5, that will be 12,000 hour total for the span of 5 years. Okay, this is a way to solve to find the average life in this type of problem. They won't be mentioning the exact criteria, but we have to assume the rest. Okay, for the case of week, we have to assume 5 working day. Similarly, for total number of days in a year, we have to assume 300 working day. All right. So next thing, we have to find the life of the bearing revolution. This is a factor we need to apply in the problem. Okay, that's we can find by using this formula 60 into n into LH. Okay, so this formula is also in data book. We know the value of n, they have given the RPM. This LH value is what we just find out, the average life of bearing, that is what we just find out. So simply substituting, you get the life of bearing revolution. Okay, we need the value in revolution. In data book you may find it with 10 raised to 6 all the thing, but we don't need the value of 10 raised to 6. If there is 10 raised to 6 in the denominator, that means we'll get the and the life of the bearing in millions. We don't need the value of million, we need the value in revolution. So in order to get the value of revolution, you have to multiply it by 10 raised to 6. That's why there is no 10 raised to 6 here. Okay, in some data book there will be 10 raised to 6. We don't need 10 raised to 6. You only need the value in revolution. So this will be the equation you need to by heart. So this much revolution you will get. Next factor we need to find is a dynamic equivalent load. This is the equation to find dynamic equivalent load. So for that we need to find a term called FA by CO. So you need to find the value of FA by CO. So FA is the axial load. We know that CO is the static load factor. Okay, that's the static load rating that will be CO. So we have to we don't know the value of CO, but we know FA. But we'll simply assume FA by CO to be 1.5. Based on that, this will be the data book page for the next step. So this is the value we'll be looking FA by CO. Okay, we don't know the value, which is assuming to be 0.5. So this whole we'll be looking into this whole line. Okay, so based on that, we need to find the value of x and y to substitute in the dynamic load equation. Okay, so how do you find x and y? Okay, for that you need to find the value of FA by FR. We don't know the value of V is the rotation factor. We are assuming it to be 1, and all the question will be assuming it to 1. So FA by FR is the next thing we have to find. That will be 0.6. So based on this table, you can see we know the value of V is equal to 1. So this is the value of E value. So as we already assume FA by CO to be 0.56. So based on that, the E value will be 0.44. And FA by FR, we got the value as zero point 0.6. So that zero point 0.6 is greater than E. Am I right? So you can look at the different condition we have. Uh, Here we have FA by FR is greater than E. Okay, all other is just the opposite. Here it is less than. Here it is less than. Here FA by F. We know the value of V equal to 1. So remaining only FA by FR will be looking. So FA by FR here greater than E. So for the X value, the corresponding value will be 0.56. Next, we need to find the value of Y, right? We know this is the data table we're looking. So here also we know FA by FR greater than E, right? And since we already know this is this last line will be the set, the corresponding value will be this one. Okay, so X value is 0.56 and Y value will be 1. Is only the assumed based on the assumption FA by C equal to 0.5, right? Now we can substitute and find the equivalent load. We have all the value. So based on that, you got 2,900 note. Okay. Next step is we have to take this equation from the data book. Here also we need to find the value in revolution. So you can find this equation data book. We have to take specifically for the ball bearing equation. Okay. For ball bearing, the K value will be 3. We will find this equation in the data book. So from that, you can see we know the value W. What is Ln? This Ln is the life in revolution we just found earlier. Okay, that 720 into 10 raised to 6 revolution. From there you get the W as C value as 25.9 kilonewton. Okay, this C value is the dynamic and this C0 is static. Okay, based on assumption value, we got the value of C as how much? 25.9 kilonewton. Okay, that will be around 25,000, right? So he can see all the range of value. So next value according to this range will be this one, right? 27,070. So this whole line will be our consideration, and this is you can see this all specification. This 50BC02 is the, in this question they are asked to select a ball bearing based on estimation. So this 50B0 C02 will be the series of bearing based on the numerical similar value. Okay, so we know the value of C as 27,070. So the corresponding Z0 is 20,595. So we need to find this actual dynamic equivalent load again, because based before that we just found by assumption value. Now we got the actual CO based on this methodology. Now the actual value of static load rating is 0 is 20,500, which is the actual value. Now we need to again look into W by CO. This is same as FA by CO. Okay, this W by CO is same as FA by CO. So now we got the value of 0.07. again V is equal to 1. We need to find again Fa by Fr plus 0.6. Now we need to again find the value of X and Y in order to substitute into this equation to get the actual W. So how do we do that? We know the value, actual value of WA by C is 0.07. Okay, so now we know the actual value of FA by C is 0.07, but here we don't have the 0.07, but next value according to that is 0.08. So we will be considering this whole line. All right, and we got the value of FA by FRS point 6, right? Point 0.6, right? So that point 0.6 is obviously greater than point 0.2, right? 0.28, right? So we need to value of X and Y. X is again we already I already explained it earlier. Fa by Fr greater than E, because Fa by Fr is 0.6, and based on this the E value will be 0.28. So obviously 0.6 is greater than 0.28. So this will be the condition. So the X value will be 0.56. So what the value of Y? We cannot take why the one, like I mean this row as LB, because this is our row, right? This is our row, so the corresponding y has to be taken by from this, and this is the condition that satisfies, right? Fa by Fr is greater than, obviously this is the set of column we need to take, and as we already know, this is the line we'll be considering. The corresponding y value will be 1.55. So we will be taking a rounded figure, so the value will be 1.6. We got the actual value of I mean X and Y, and so Y will be 1.6. So we can again find W. The actual W will be 3800 Newton, and the material or the current specification of the pairing will be 50B0C02. This will be the series using. So you also need to write this to complete this problem. They are asked to choose the ball bearing. So this will be the ball bearing as a number 50B02. This will be the ball bearing, and this is a way to solve this problem.